Physics, Part 193. Whether or not emission takes place depends only on whether the frequency of the radiation used is above the threshold for that surface. It does not depend on the intensity of the radiation. For a given frequency, the rate of emission of photoelectrons is proportional to the intensity of the radiation. Another experiment using the apparatus shown in the figure can be carried out to investigate the energies of photoelectrons. If ultraviolet radiation of a fixed frequency above the threshold is shown onto the metal surface A, it emits photoelectrons. Some of these electrons travel from A to B. Current is detected using the microammeter. If a potential difference is applied between A and B with B negative with respect to A, any electron going from A to B will gain potential energy as it moves against the electric field. The gain in the potential energy is at the expense of the kinetic energy of electron. That is, loss in kinetic energy is equal to gain in potential energy, is equal to charge of electron into potential difference. Well, experiment to measure the maximum kinetic energy of photoelectrons. If the voltage between A and B is gradually increased, the current registered on the microammeter decreases and eventually falls to zero. The minimum value of the potential difference necessary to stop the electron flow is known as the stopping potential. It measures the maximum kinetic energy with which the photoelectrons are emitted. The fact that there is a current in the microammeter at voltage less than stopping potential indicates that there is a range of kinetic energies for these electrons. If the experiment is repeated with radiation of greater intensity but the same frequency of the maximum current in the microammeter increases, but the value of the stopping potential is unchanged. The experiment can be repeated using ultraviolet radiation of different frequencies, measuring the stopping potential for each frequency when the maximum kinetic energy of photoelectrons is plotted against the frequency of the radiation. The graph of the figure is obtained. Graph of maximum kinetic energy of photoelectrons against the frequency of radiation. The following conclusions are drawn from this experiment. Number one, the photoelectrons have a range of kinetic energies from 0 up to maximum value. If the frequency of the incident radiation increases, the maximum kinetic energy of the photoelectrons also increases. For constant frequency of incident radiation, the maximum kinetic energy is unaffected by the intensity of the radiation. Number three, when the graph of figure is extrapolated to the point where the maximum kinetic energy of the photoelectrons is 0, the minimum frequency to cause emission from the surface, the threshold frequency, may be found. At the time when photoelectric effect was first being studied, it was fully accepted that light is a wave motion. Evidence for this came from the observed interference and diffraction effects. The conclusions of the experiments on photoemission produced doubt as to whether the light is a continuous wave. One of the main problems concerns the existence of threshold frequency. Chemical wave theory predicts that when an electromagnetic wave, that is, light, interacts with an electron, the electron will absorb energy from it. The electrons will absorb energy from it.